Hey everybody, my name is Calvin and welcome back to my channel. Today, we're doing a simple beginner-friendly Docker tutorial. If you've ever heard developers talk about containers, images, Dockerfiles, and Docker Desktop, but if you've never understood how they fit together, this video will hopefully help you make sense of that. So, first, what is Docker? Docker is a platform that lets you package an application along with everything it needs to run into a single portable unit called a container. So a lot of applications depend on specific library versions, runtime environments, system packages, operating system differences, and when any of those differ between machines, right, your software is going to inevitably break. So the point behind Docker is that it avoids all that by creating these containers, which are lightweight, isolated environments that always behave the same no matter where you run them. So if it works in your container, it works on any machine, whether that be Windows, Mac, Linux, a server, or the cloud. The consistency is the main reason Docker has become so popular. Diving deeper into a container is a running instance of an application that is bundled with all its dependencies. And you can think of it as a small self-contained computer within your computer. As in, it has its own file system, its own libraries, its own environment, its own startup commands. It doesn't interfere with your machine, and your machine doesn't interfere with it. A container is like a sealed take-home meal box. Everything that app needs is inside the box, and no matter where you take it, it works the same. Another term that you'll need to know is an image. An image is the blueprint or template for a container. It's a frozen snapshot that contains the application code, system libraries, dependencies, config, and the operating system layer that is required to run the app. A container is simply running a version of that image. If the containers are cookies, then images are the cookie cutter. We'll also need to know what a Dockerfile is. To create an image, we write something called a Dockerfile. A Dockerfile is just a text file with instructions that tell Docker which base image to start from, which files to copy over, which packages to install, which port the app uses, and what command runs the application. And Docker will read the file from top to bottom and build an image from it. So let's talk about Docker Desktop, because this part confuses a lot of beginners. We're going to need Docker Desktop as it is the tool that will actually run Docker on your computer. It gives you a background engine that can run containers, a lightweight virtual machine that Docker uses behind the scenes, a simple dashboard to see running containers and images, it's an easy way to configure networking resources and volumes. It's integrated with your local file system. It has automatic updates to the Docker engine. And on Windows and Mac OS, Docker can't run natively and requires a small Linux-based virtual machine because containers fundamentally use Linux kernel features. So Docker Desktop will help us provide that VM automatically, so you don't have to deal with virtualization settings yourself. So that's why we're going to be downloading it. To download it, we want to go to docker.com. And we want to hover over download Docker Desktop. Download whichever fits your computer architecture. In my case, my computer supports AMD 64, so I would click on that. I've already downloaded it, but the process for getting Docker Desktop onto your computer is very easy. You just click on it. It'll download an executable. It'll download a setup wizard, and you just follow the steps, and it'll be downloaded on a computer. If you've successfully downloaded Docker Desktop, this is what it'll look like. In order to verify our installation of Docker, we can also go to a terminal. And we can type in this command, docker --version, and we can see that we've successfully downloaded Docker. Now that we've downloaded Docker, what do we do now? Let's run our first container using Docker's built-in test image called hello world. We can do this with the command docker run hello-world. And you can see that a container has opened up. Behind the scenes, Docker Desktop looks for the hello world image. We don't have it on our computer, so it downloads it from Docker Hub. It creates a container from said image, and then it runs that container, and then the container prints a message and exits. We can see that it's working correctly based on the terminal output. Now I'll walk you through building your own container from scratch. So we'll create a simple Python web server using Flask. So we're going to be I've already made the directory. I've already made the project folder. It will have an app.py, the Docker file that I mentioned that we talked about before, and the requirements that we need. This is our web server right here with a very simple endpoint. And this is our simple Flask web server. It's a tiny Flask app that returns a message when you visit the home page. So in this case, it's hello from inside a Docker container. Second, we want a requirements.txt. The requirements.txt will just simply have your dependencies, which the Docker file can use for later. Finally, jumping into the specific Docker file, this is where it gets a little complicated. First, we want to have a line that looks like this from Python, which starts a lightweight Python image. We will also want to set the working directory inside the container, which in this case is /app. Given that we also want to we want to copy the project files into the container, so in this case we want to copy app.py into our container because that's our actual Flask app, and our requirements.txt, which contain our dependencies. Our fourth step here is to install the Python dependencies within the container. So in this case, in order to download our dependencies, we can run pip install -r requirements.txt, which will download Flask, which will download the contents inside requirements.txt into our container, which in this case is just Flask. Then our fifth step is going to expose the port as to where our web server will be hosted. In this case, we're just going to set it at 8,000. And our sixth step is a command to start the app inside the container, which is just simply Python and app.py. Whoops. Now that we have all the files that we need, let's build our container. The command for this is simply docker build -t, and the -t flag will allow us to name the image. So we'll just call it simple Docker app for now. And now it'll start building a complete environment based on our Docker file. You can see that it's following all of our directions in the Docker file. Next, we actually want to run the container. So we can do this with a simple command as well. Docker run -p 8,000 and we'll have it run at port 8,000, and we'll run simple Docker app. The -p flag maps port 8,000 inside the container to port 8,000 on your computer. We can do this with a simple command, docker run -p 8,000, and we'll add the name of the image, which in this case is just simple Docker app. We can see in Docker desktop that we've created the container, and we have our image, simple Docker app at port 8,000, and we can see that it's running right here. Now we can access our web app at port 8,000. I've already had this handy dandy up here, and we can see hello from inside a Docker container. See that the Flask app has successfully been used from Docker. Now, when you're done using Docker and you don't need it anymore, we can do Control-C to quit the web service, or we can also use Docker PS, which gives us a name of which gives us the details of all the running containers. In this case, since we just shut it off, none of the containers are running, but say we ran it again, and we ran docker ps, we'll see that pops up. And then from here, we can also just do docker stop and the container ID. And this will stop our Docker container. So, to sum it all up, the Docker file describes how to build an environment. Docker Desktop will then use that Docker file to build an image. We start a container, which is that image running in isolation. Docker Desktop will handle the virtualization and networking for us behind the scenes. And we can access the container through localhost at through port 8000 as if it were a normal app. That's the power of Docker. Your environment and your code become a single portable unit that can work from anywhere. And that's the simple Docker tutorial. You now have a fundamental understanding of containers, images, Docker files, and Docker Desktop, and we walked through how to build your first containerized app. Obviously, our app is rather rudimentary, but you can imagine you can definitely imagine the complexity as apps get bigger and bigger. If this was helpful, leave a like and subscribe. Thanks for watching, and I'll see you guys next time.